Hello everyone. So we'll start the topic of electrostatics. It is very easy and we can cover it within half an hour. We'll divide it into two parts, part 1 and part 2. According to the syllabus of Osstet and contractual teacher, we will study this. And so we'll start from Coulomb's law, force due to discrete and continuous charge distribution, electric field lines, electric field and dipole, electric flux, Gauss Law and its application. These topics we will cover today, and in the next day we will cover these topics. Okay, so let us start with Coulomb's law. What is Coulomb's law? Coulomb's law is nothing but the force between two charges, force between 2 point charges. Two charges Q1 and Q2 are separated by a distance R. Separated by a distance R. Then the force between them is given by Coulomb's law. It is given that force is directly proportional to product of the charges and inversely proportional to square of the distance between them. And combining this, we can write the constant is 1 by 4 pi epsilon naught into Q1 Q2 by R square, where 1 by 4 pi epsilon naught is constant, and the value of constant 1 by 4 pi epsilon naught is 9 into 10 to the power 9 Newton meter square per Coulomb square in MKS system and 1 in CGS system. Two types of system we know, MKS and CGS. So accordingly, the value will be used while solving the numerical. बहुत easy. So आपको नहीं कि हमें क्वेश्चन दे तीनटा कर दबा केमिति नॉर्मली केमिति क्वेश्चन पचारुची म ताकू करेबी. Okay. So question number 1 आपको नहीं कि आसीओ. If the distance between two charges, distance between two charges reduced to half, then the ratio between new force to original force is, okay, this type of question will be asked and 4 options will be there. You have to find which is the correct option. So how to solve this? So let us see. Given initially force is K, constant, suppose I write K Q1 Q2 by R square, and in the second case F prime equal to K, charges are same Q1 and Q2 by distance is R prime square. What is R prime? R prime is reduced to half. This is given here, reduced to half, or it may given it is increased by twice or it is decreased by 50% or 20%. Accordingly we have to calculate. Reduced to half means R by 2. R becomes R by 2. R prime becomes R by 2. So it will be K Q1 Q2 by R by 2 square, which will be equal to 4 times of K Q1 Q2 by R square. That means 4 into F, because F is K Q1 Q2 by R square. So now the ratio between new force to original force. New force is F prime by F. You can say F prime is 4F, original force is F. So the ratio is 4 by 1. So like this you have to simplify. This is one type of numerical you can get in the exam. Another type of numerical I'm saying, question 2, it will be given question 2, it will be given that when two charges of same magnitude, two charges of same magnitude are separated by a distance r, and placed in contact, then placed at a separation of r by 2, then find the ratio of nu first to original. So question is given here, when two charges of magnitude q and 2q are separated by a distance of r and placed in contact and then placed at a separation of r by 2, then find the ratio of new force to original force. So initially in the diagram you can see सबु जिनसर जदि डायग्राम कर दबा हमको बहुत इजी हो करिया पई. ओके, q to q initial distance is r and after some time they are placed in contact, so total charge will be 3q and after separation their charge will be equally divided, it will be 3q by 2, 3q by 2. So now initial force is F equal to, you know the Coulomb's formula, k q into 2q, that is 2q square by r square, that is 2kq square by r square, and finally k into 3q by 2, 3q by 2, and the distance is r by 2. This is very very important. आपको skip कर जानते r by 2 square, so it is 9q square by 4 into r square by 4, so 4 cancel, 9kq square by r square, so it is 9f, so it is f, it is sorry, it 9f कोई परिवार नहीं होता 9f कोई परिवार नहीं, because f is 2kq square by r square. Okay, fine, then f prime by f, if we will take kq square by r square will be cancelled and the answer is 9 by 2. So option will be given, you have to find out the correct option. This is another type of question and very easy type of question related to this Coulomb's law I am writing. Just see. So question will be given like that. If two charges, similar charges separated by distance this and experience a force of 10 to the 10 Newton. So you know the formula, F equal to k q1 q2 by r square. So in this case two charges are same, k q q by distance square, distance is distance square. So F value is given 10 to the 10 Newton, k value you know mk system 9 into 10 to the 9 and it is q square by, here you will get r square is 10 on 10 centimeters, so you have to convert it into meter, so 1 by 10. So what you will get there implies that 10 to the power 10 equal to 9 into 10 to the power 10 into q square. So 10 to the power 10, 10 to the 10 will be cancelled, q square will be 1 by 9. So q will be 1 by 3 plus or minus 1 by 3 Coulomb. So option will be given 0.3 Coulomb, 0.3 Coulomb, like that you have to choose the correct answer. And if question may be asked like this, two charges 10 Coulomb and 40 Coulomb are separated by 20 centimeter. Find the position between them. Find the position between them where a third charge 20 Coulomb placed in equilibrium. Third charge will be placed and it will be in equilibrium. So how to find the answer? Let us see. It is also very easy. Two charges, 10 Coulomb and 40 Coulomb, separated by distance 20 centimeter. So a third charge is placed in between them, that is 20 Coulomb. Distance we have to find. What is the distance? Suppose this distance is x and this distance will be 0.2 minus x, because I am taking in MK system. So we can say 10 Coulomb experiencing force on 20 Coulomb in this direction and 40 Coulomb charge experiencing force on 20 Coulomb in this direction, and both the forces should be equal. Then only we can say it will be in equilibrium. The force experienced by 10 Coulomb on 20 Coulomb, suppose F1, and force experienced by 40 Coulomb on 20 Coulomb is F2. Then we can write F1 equal to F2. In that case only we can say the 20 Coulomb charge will be in equilibrium. So F1 value will be what? K into 10 into 20 by distance x square, and in this case K into 40 into 20 by 0.2 minus x whole square. So after cancelling we will get 20 will be cancelled, 40 and 10 it will be 4. So by simplifying you will get 4x square equal to 0.2 minus x whole square, and you will get 2x equal to 0.2 minus x. So 3x is 0.2. So you can find here x value is 0.2 by 3 meter. Okay. So according to the option you have to choose the correct answer. So now let us move for a number of charges, force due to a number of charges. Force due to a number of charges. These are the cases of two charges. If more than two charges are there, how to find the force between the force of the system? How to find? Three charges are placed in triangular pattern. So this is Q1, this is Q1, this is Q2, and this is Q3. And you have to find force on Q1, force on Q1, on Q1. How to find? So we have to see the sign. All are positive given here. So Q2 will experience force Q1 on Q1 in this direction, repulsion force. Like charges repel each other, you know. So this is F21, and similarly, because 2 and 1 charges are there, similarly Q3 will experience force on Q1. So in this direction, because it is also repulsion, F31. Everything is in that diagram mentioned clearly. See, we have to find force on Q1. Q1 upare force paiba, kemiti paiba? Q1 upare force pakebo Q2, Q1 upare force pakebo Q3. Okay, so Q2 will experience force in this direction, F21 vector. Q3 will experience force in this direction, F31 vector. And F21 formula you know is K Q1 into Q2 by distance square. This distance will be given in the question, and this distance will also be given, R1 square, and F31 equal to K Q1 Q3 by R2 square. I am saying an example. If charges will be given, we will do another example for this. So it is for your understanding. So now how to find the net force at Q1? Two forces are there. Net force kemti paiba? Gote epote jauchi, gote epote jauchi. In this case, net force how to find? This is the direction of net force, and we have to know this angle. This force is F1, this force is F2. Then this force, how to find? Net force can be find out by root over of F1 square plus F2 square plus 2 F1 F2 into cos theta. Okay, so F1 F2 पाइला परे हमरो काम सरीगो नाही ताको हमें फाइनली नेट फोर्स पाइबा ए डायरेक्शन रे नेट फोर्स आसीओ हमको ए एंगल टा जानिया पई पड़िबो गोटे एग्जांपल करले तमे जानि परिबो सपोज एन इक्विलेटरल ट्रायंगल इज गिवन example equilateral triangle is given all sides are 10 centimeter all sides are 10 centimeter that is 0.1 meter and three charges are placed at three corners minus 10 coulomb 20 coulomb minus 30 coulomb. In this case, suppose we want to find force on minus 10 coulomb. Force on minus 10 coulomb. So what we have to do? We have to see the direction of forces first. Minus 10 coulomb and 30 minus 30. So it will be like charges. So force will be in this direction. F1. And on minus 10, 20 will experience attractive force in this direction. F2. And this angle is 60 degree, this angle also 60 degree. So this angle will be 120 degree. So F1 value you can find K into 10 into 30. Minus symbol will not be used, minus plus symbol will be used only for finding the direction. The distance is 0.1 square. And F2 F2 value is K into 10 into 20 by 0.1 square. Okay, so this is F1 and F2 value, and then you can find F by taking square root F1 square plus F2 square by using the formula 2F1 F2 cos 120. Cos 120 value is minus half. So after using, you can find. Okay, so like this, for a square, if given 4 charges are there, square Q1, Q2, Q3, Q4. Q1 here minus Q2, here Q3, here minus Q4. Find the force at center, net force at center. How to find? To find the net force at center, Q1 is repulsive force. Another charge will be placed here, Q suppose. So Q1 will experience force in this direction, minus Q2 will experience force in this direction, and F3 will experience force. F3 is positive, so it will in this direction, F3, and F4 will be in this direction. Then we have to find the resultant force. F4 and F2 are in opposite direction. Their force will be cancelled, and we have to find the net force. F4 difference F2. Similarly, F3 and F1 in opposite direction. We have to find their net force by difference, taking the difference F3 and F1. Then we have to convert them into this manner. Then we can find the net force. So we have to solve some numerical related to this, which I will provide in PDF format to you. Numericals you will solve and you can find, and the examples also I will share. So now let us move for electric field lines. Electric field lines. Electric field lines. This is the imaginary line. Lines means these are straight lines. These are imaginary line around a charge. The positive charge is there, then the field lines will emerge from it, and the field lines will give the direction of electric field at that point. And for a negative charge, the field lines will be entering into it, and field lines are always normal to the surface. These are some properties. And for positive and negative pair of charges, field lines will be like this. They will start from positive charge and end in negative charge, like this. And electric field intensity is very, very important. Electric field intensity. How to find? Intensity means the measurement of the field at any point. If a charge is there, 10 coulomb charge is there and 20 coulomb charge is there, obviously you can say in case of 20 coulomb the field strength is more than that of 10 coulomb. Okay, because magnitude is more and it will produce more field lines. The charge which will produce more number of field lines having more field strength. For 10 coulomb charge, how to find the field at a distance of 5 centimeter or 10 centimeter or at any distance. Field strength can be found out by taking the ratio of force experienced by the test charge. Force by test charge. Suppose charge Q is here and we want to find electric field at a distance R. Then place a test charge Q naught here. Then force between them is K Q Q naught by R square. So at this point, field will be what? Field intensity will be F by Q naught. So by taking the ratio, we will get KQ by R square. So electric field intensity is K into charge by distance square. Force was K Q1 Q2 by distance square. Electric field is KQ by R square. For a single charge, we can find the field. But to get the force, we need two charges. Okay, and the unit of field strength, SI unit, for force it is Newton, for charge it is Coulomb, SI unit. Okay, so next move to dipole, electric dipole. So related to these problems I will do in the next class. So dipole, what is dipole? Di means two, di means two, and pole means charge. Two charges. It is a system of two charges equal and unlike. If it is plus Q, it is minus Q. Equal and unlike. Q value is same and one is plus, another is minus. And separated by a small distance. Generally, we will write this distance as A to A. And this is the center of dipole. And this dipole has two directions. This direction is called as axial line. Along the axis, axial line, and any line perpendicular to the axial line and passes through its center is nothing but equatorial line. Okay, and I have told the direction of field lines is from positive to negative charge, but in this case the dipole strength direction is from negative to positive charge. Negative to positive charge. Direction of dipole. So many times this question has also been asked. Direction of dipole, negative to positive charge. Again, strength of dipole. How to find the strength of a dipole? Dipole strength or dipole moment also we will tell it. Or dipole moment. Dipole moment symbol is small p, which is given as product of one of the charges into distance between them. Its unit is Coulomb into meter. Cm normally we will confuse it by reading that centimeter. It is Coulomb into meter. Okay. So now this dipole strength is Q into 2A, and to find the field due to dipole, question will be given to find the field due to dipole. So dipole means there are two axes, one is axial line, another is equatorial line. If two charges Q plus Q minus Q are separated by distance 2A and along axial line at a distance R from the center we want to find field, and at a distance R from the center along axial line we want to find the field, then I am saying the formulas. In axial line, formula is 2 Kp by Rq, and in axial equatorial line it is electric field intensity is Kp by Rq. Everything will be given, and another formula, torque due to dipole. Torque due to dipole. When a dipole is placed in field, torque will be experienced. Torque means rotating force. That formula is Pe sin theta. Remember this formula? We will do numericals related to all this field and dipole, torque due to dipole in the next class. Thank you for today's class. We'll see again. So revising these topics. Okay. So numerical based on electric field intensity and dipole. Formula of electric field kq by r square and dipole moment p equal to q into 2a. Electric field along axial line 2 kp by rq and along equatorial line kp by rq, and torque due to dipole is p sin theta or in vector form p vector plus c vector. Now this is very important for a dipole. Net charge is 0 always and net force is 0 when it is placed in uniform field. What is uniform field? Uniform field is a field in which the strength of electric field intensity, strength of electric field is same everywhere. If we will take any 2 points A and B on the field strength is same for both the points. And for the non-uniform field, if we will place a dipole inside non-uniform field, net force will not be 0. This is the main difference. Net force will not be 0. And torque exists in both uniform and non-uniform field. This is very important. Combining on these sentences, so many times question has been asked, which sentence is correct. Now find the amount of charge to produce field strength of 100 Newton per Coulomb at a distance of 10 centimeter from the charge. So everything given, E equal to kq r square formula you know, and E is 100 Newton per Coulomb given, K value 9 into 10 to the 9, Q you have to find 10 centimeter, you have to convert into meter, 10 by 100 is 1 by 10 meter, which is equal to 9 into 10 to the 10 Q. So Q will be 1 by 9 into 10 to the 8, which will be 0.111 into 10 to the minus 8. And in standard form, you can write it like this, 10 to the minus 9. Because 9 is nanocoulomb. So option will be given like nanocoulomb. Next question, a charge of 10 nanocoulomb held stationary on an electric field experiencing gravitational pull of 20 Newton. The charge is experiencing gravitational pull in the vertically downward. Always gravitational pull will always vertically downward, which is 20 Newton, and electric field should be in opposite direction. Okay, to make it stationary. Stationary means it is at rest in equilibrium position. So the two forces should be same. Electric force formula from the electric field, we know E equal to F by Q formula. First definition is electric field strength is force experienced by the charge. So force due to electric field is Q into E, which is equal to mg. So you can find here the value of E, electric field strength. So next we'll move to the another question related to electric field. Dipole of strength 100 Coulomb into meter is placed at an angle of 60 degree with the field. If one of the charges of the dipole is 10 Coulomb and the distance between them is 20 centimeter, find the electric field to give a torque of 100 joule. So you know formula, tau equal to PE sin theta. So tau is given 100 joule and P you have to find Q into 2A, E sin 60 degree, Q is 10 Coulomb, 2A means the distance between them 20 by 100 into E into sin 60 is root 3 by 2, 0 0 0 0 cancelled, and 100 equal to E into 2 root 3, 2 to cancel, 2 to cancel. So in that only root 3 cancelled. So E equal to 100 by 3 is equal to 100 root 3 by 3. Equal to 100 by 3 into 1.732. And after multiplying, we can 173 by 3. which will be approximately, the value will be 3 value will be 57.6.
କହିଲ ଆରେ ଶୁଣ ଟିକେ ଏ ଯୋଉ ଡିଷ୍ଟାନ୍ସ ଟା କହିଲ ଯୋଉ 2a ଟା ହେଲା ଯୋଉ ଡିଷ୍ଟାନ୍ସ
So in the diagram, to find the net field at centroid, what to do? So we have to see what are the charges and what is the distance of the centroid. Distance of centroid in this diagram I have explained. If the side of the equilateral triangle is A, then the distance of centroid from the vertex will be A by root 3. A by root 3. So in this case, side is 20 centimeter, that means 0.2. So all the distances of the centroid from the vertex will be 0.2 by root 3 vector. Now, EA means field at the centroid due to charge at A, 10 Coulomb. K into 10 by distance square. Similarly, EB, and the direction is shown here. Direction is shown by the arrow mark in the diagram. And EB is K into 20 by 0.1 by root 3 whole square. Similarly, EC is in this direction because EC is negative. Negative means towards and positive means away from the charge. So EB in this direction, EA in this direction, EC in this direction. Now we have to find total field at this point. At the centroid, total field how to find. So first find EA and EB resultant. So process is EA and EB resultant how to find. Parallelogram law vector addition, that is EA square plus EB square plus 2EAEB cos 120. You know the value of EA and EB. From using this formula you can find. And then after finding this, E prime, that is the resultant of E and EB, also in same direction of EC. So now final field will be the sum of the E prime and EC. That is the final answer. Like this you have to solve the electric field for a system of charges. Now let us move to the next question. So the last part of the topic, that is electric flux and Gauss law. Electric flux means number of field lines linked with an area. Number of field lines linked with an area. This is a area and the field lines are entering and leaving through the area. The field lines occupy some area. Suppose this is area S vector and electric fields are E vector, then flux symbol is phi. The flux phi is given as E vector dot S vector, or you can write it ES cos theta. Flux is scalar quantity and number of field lines more, then flux is also more. Or we can write it continuous form integration E vector dot ds vector. Okay. Simply dot product of electric field and surface area vector is flux, and its unit is flux is electric field area. So its unit will be SI unit will be electric field unit is Newton per Coulomb and area unit is meter square. And dimension also can be asked. You can find the dimension of electric field and area. Electric field dimension may be asked in question also. Dimension how to find. Electric field is F by Q and area you know L square. F means MLT minus 2 and Q means IT. IT means ampere into time into L square means L square. So dimension, so M L Q T minus 3 A minus 1. Dimension may be asked in many times. So this is about flux which is a scalar quantity, and Gauss law, introducing Gauss law to the flux concept. Gauss law is saying the total flux linked with a closed surface. Total flux linked with a closed surface. This is important. With a closed surface will be equal to 1 by epsilon naught times total charge enclosed within the surface. Okay, so phi equal to q by epsilon naught. Giving a simple example, this is a circle of radius 2 centimeter and origin at center is at origin, and position of charges are given. Position of charges 2 Coulomb, -4 Coulomb and 6 Coulomb at -1 0, -1 1 and 3 0. What is the total flux? What is the total flux? So you have to locate the charges here. -1 0 means in this side -1 0, 2 Coulomb is there, and -1 1. -1 1 means -1 and 1 both will lie inside the sphere, inside the circle. -1 1. So here 2 Coulomb, here -4 Coulomb, and 3 0 means outside. 3 0 point is outside, here 6 Coulomb. So net charge inside is 2 Coulomb. For -4 plus 2, net charge inside is -2 Coulomb. So flux will be -2 by epsilon naught. This is the answer. Q by epsilon naught. 2 by epsilon naught. Okay. So total flux means total charge inside by epsilon naught. So this is how you have to solve, and we'll solve more question in the PDF. So first problem related to dipole. Two charges plus or minus 5 microcoulomb are placed 1 millimeter apart. Find the dipole moment. Dipole moment formula is one of the charges into distance between them. So charges is 5 microcoulomb. For micro, 10 to the power -6 will be written. So 5 into 10 to the power -6, and millimeter to be converted into meter, 10 to the power -3. So पिला इटी भूल करंती माइक्रो जगह माइक्रो टाकू सेमती 5 ही लेखिकी छाड़ी दियंती, जाफल कि ऑप्शन रे थिबो 5 into 10 to the power -3 भी ऑप्शन रे थिबो, पिला सेटा को टिक मारी की पळेबी आसीबे. ओके, से भूलटा हुए. तो सब बेले यूनिट कन्वर्जन इज वेरी वेरी इंपोर्टेंट. सेटा सब बेले मन रखियो. सबु एमके सिस्टम रे कन्वर्ट करिया पई पड़िबो. नेक्स्ट, calculate electric field due to an electric dipole of length 10 centimeter. Dipole length means a length amara -1 microcoulomb to +1 microcoulomb length 10 centimeter, having charges of +or-1 microcoulomb at an equatorial point 12 centimeter from center of dipole. So equatorial point means this line, perpendicular line, 12 centimeter the center to electric field formula. So dipole electric equatorial line formula में पढ़ी थी 2 kp by r cube, बातार आउ गोटे फॉर्मूला होची k into 2 qa by r square plus a square all to the power 3 by 2. याकू जनरलाइज कले 2 kp by r cube हुए. So k value is 9 into 10 to the power 9 constant. q देइची microcoulomb 10 to the power -6 बसेवा. 2a distance, 2a is 10 centimeter, that means 0.1 meter by r square plus a square. R square means distance, this distance is r equal to 12 centimeter, that means 0.12 square plus a square. A square means 0.1 by 2. 0.1 by 2, that means 0.05. 05 square, whole power 3 by 2. which will be 9 into 100 divided by 0.13 square, which will be equal to 4.096 into 10 to the power 5 Newton per Coulomb. So out a question kariba. In this case, question number 3, we have to find electric field on the axial line. Axial line formula, another formula, charge our distance at separate data formula pokeva K into 2 PR by R square minus A square rho square. Axial line out formula. So K value 9 into 10 to the power 9. 2 P is Q into 2A. Q mane 5 into 10 to the power minus 6 micro achi into 2A. Distance is 4 centimeter and 0.04 into R. R means A distance. A distance achi R. 4 centimeters 0.04 again by R square 0.04 square minus A. A is 2 centimeter, that means 0.02 square whole square. तब solve कले हिस्सा 10 to the power 8 Newton per Coulomb. ताको कम समय मध्य केमती solve करिया पे पड़ियो. Calculation टी फास्ट करिया पे पड़ियो 9 to 18 18 5 90 90 into 16 144 10 power सब 10 रो power को पक्को आने की कोई calculation टी करिया पे पड़ियो. So एमिति टाइप रो क्वेश्चन आसीबार संभावना अछि. Flux. Flux means area will be there and some electric field lines will be there, and when field line will link with the area, then we will get flux. Flux formula is electric field. This is electric field and the area direction is in this direction, S vector. Area direction means perpendicular to the surface. Direction of area means perpendicular to the surface. That is the normal vector. E vector dot S vector. Flux will be 0 when E vector is perpendicular to S vector. Electric field vector is perpendicular to S vector. E dot S means dot product formula hochi ES cos theta. Theta hochi angle between kaha vitre angle between electric field vector and S vector S vector. S vector means area ro direction. This is S vector. This is the direction of area S vector. This is the area S. Then its direction will be perpendicular to the area. This angle is theta. Suppose this is a plane. This is a plane, and the area vector. This is S vector. S area S, and its direction is in this direction, perpendicular to the area S vector. And if electric field lines are in this direction, then in this case theta will be 0 degree. That means electric field is parallel to S vector. Electric field is parallel to S vector, but perpendicular to the surface. But we can say electric field is perpendicular to the area or normal to the area. This is the difference. Perpendicular to area, parallel to area vector but perpendicular to area. In this case, perpendicular to area vector means this is area vector in this direction. So electric field will be in this direction. That means electric field will be parallel to the surface. Electric field is parallel to the area. Area means the normal surface. Area vector means perpendicular to the area. And we always see the angle between area vector and electric field. This is, we have to consider 90 degree. And in this case, they are parallel means theta is 0 degree. So related to this, numericals are there related to flux, electric flux. And after combining with Gauss law is saying that total flux linked with a closed surface is 1 by epsilon naught times 1 by epsilon naught times total charge enclosed. If this surface has charge q, then flux linked with the surface phi equal to q by epsilon naught. So flux have two formula. Flux is q by epsilon naught. Flux is dot product of electric field and area vector. So related to this, let us solve some numerical and we'll get clear idea about this. So let us move with the first question. So question given, electric field in vector form given 6 I cap plus 3 j cap plus 4 k cap and flux to the surface area 20 units in YZ plane. YZ plane means this is, suppose this is x-axis, this is y-axis, and this is z-axis. This plane is YZ plane. And the direction of YZ plane means what? I have told direction means perpendicular, means x direction. X direction means I cap. Y direction means unit vector j cap. Z direction means unit vector k cap. And this area is 20 units. So its direction means perpendicular to YZ plane. Perpendicular to YZ plane is what? That is x-axis. And along x-axis, what we will write? For x-axis, we will write unit vector I cap. So area vector, in this case, electric field is given. Electric field is given 6 I cap plus 3 j cap plus 4 k cap. And area vector, S vector is here. 20 units means the value is 20 and the direction is along x-axis because perpendicular to YZ plane. YZ plane perpendicular kiya na x-axis. X-axis direction kon na I cap. So now flux how to find E vector dot S vector, simple dot product. And dot product formula, if two vectors are given by A vector is A1 I cap plus A2 j cap plus A3 k cap and B vector is given by B1 I cap plus B2 j cap plus B3 k cap, then we know very well that A vector dot B vector is given by formula is only component wise multiplication and summation. A1 B1 plus A2 B2 plus A3 B3. Okay, because I cap dot I cap is 1, J cap dot J cap is 1, K cap dot K cap is 1. So E vector dot S vector will be what? In this case, 6 I cap plus 3 J cap plus 4 K cap dot 20 I cap. In this case, J cap component is 0, K cap component is also 0. So only we have to multiply 6 into 20, that is 120. And the unit is Newton into meter square per Coulomb. This is the answer. So let us move to the next question. Calculate number of field lines. Number of field lines jaha electric field lines, electric lines of force be same jinso. Pachatyo number of electric field lines or lines of force originating from 1 Coulomb of charge. Number of lines, kemiti paiba? Number of lines means electric flux through a closed surface enclosing the charge. Number of lines means electric flux. मन रखा पड़ो नंबर ऑफ field lines means flux को से indirectly q by epsilon naught formula. Q value is 1, epsilon naught value is 8.85 into 10 to the power minus 12. तो आपको हमें सॉल्व कर ले पाएगा 1.129 into 10 to the power minus 10 to the power plus is 10 to the power 11 Newton meter square per. Or only in this case we will not write the unit because here we have to find the number of field lines. Number of field lines means ketata field lines. So this is the number. Flux means also number of field lines. Confuse होवार किसी आवश्यकता नहीं. So next. So here will be given another diagram. Cylindrical surface is given and find the flux linked with the cylindrical surface of radius, cylinder radius given. The radius दे दीजिए. Radius is 10 centimeter means 0.1 meter and length is 20 centimeter. It means it has 0.2 meter and electric field is given by E vector is 10 to the power 5 Newton per Coulomb along plus x axis. तो माने electric field हमारा ए direction रे पड़ुची. एटा हमें confirm. Electric field ए direction रे पड़ुची. So एट गोटे जिन हमें जानिबा जोठी इलेक्ट्रिक फील्ड आ एरिया वेक्टर नॉर्मल हेतिबे से सरफेस सहित फ्लक्स लिंक होबनी जीरो हे जिवो काना ईएस cos थीटा. सो एठी सिलिंडर रो तीनटा सरफेस रहउची. सिलिंडर रो गोटे सिलिंडर रे गोटे होची प्लेन सरफेस एरिया दुई साइड दुईटा प्लेन सरफेस एरिया ए दुईटा आ गोटे होची कर्व सरफेस एरिया. एटा होची कर्व सरफेस एरिया. So curved surface area direction means normal direction. This is the direction of curved surface area, normal direction. So a case रे electric field रा normal हे जिवो ताको. Electric field is normal to the curved surface area. So flux for curved surface area is 0. तो हमें पाइबा कहा पाई plane surface area S1 and S2 पाई. Flux for S1 and flux for S2 हमें पाइबा. तापर फाइनली टोटल फ्लक्स केमति पाइबा फ्लक्स फॉर S1 प्लस फ्लक्स फॉर S2 दुटा फ्लक्स को मिसेले हम पाइबा. सो फ्लक्स फॉर S1 बाहर करिवा फार्मूला होच E वेक्टर डॉट S1 वेक्टर एरिया रो डायरेक्शन सेमति इति E वेक्टर डॉट S2 वेक्टर. सो फाई S1 केमति पाइबी ए बाहर करिवा. फाई S1 इज linked with the surface S1. E vector is 10 to the power 5 along positive x-axis. Positive x-axis रे हमें unit vector किए ना I cap. So I cap ने लो. Dot S1. S1 vector माने इस साइड में S1 नहीं चु. यारो area formula कौन? This is a curved surface area plane. तो pi r square. Pi into radius square. Radius is 0.1 square into यार डायरेक्शन कौन यार डायरेक्शन होचे पटे एरिया को नॉर्मल. सो एटा होचे नेगेटिव x रे आसीगला. दिस इज द नेगेटिव ऑफ x माने माइनस i कैप. सो इथे हम लिखिया माइनस i कैप. सो i कैप डॉट i कैप इज 1 एंड द प्रोडक्ट विल बी pi into 0.01 into 10 to the power 5 minus this is minus symbol minus pi 10 to the power 3 Newton meter square per Coulomb. Then next phi S2. Phi S2 पाइबा केमिति. Phi S2 माने right plane surface टा. So it is again E vector 10 to the power 5 and it is electric field is along positive x-axis. So it is always I cap dot area vector. This area vector along this direction, that means this is also in the same direction of electric field. So it will be pi into 0.1 square into I cap. So this value will be pi into 10 to the power 3 Newton meter square per coulomb. I cap dot I cap is 1. In this case minus, in this case plus. So total flux will be 0. Total flux will be 0 in this case. Okay. This is the answer. So option 0 will be given in the question. So you have to solve like this in the diagrammatic question. I am doing another diagrammatic question. Let us see. So again, electric field given alpha x to the power half. That means electric field is along positive x-axis. Electric field along positive x-axis. This is very, very important. Electric field direction we have to see. Alpha x means alpha is the value 800 Newton per Coulomb into meter square, and x means along positive x-axis. It is given to us. So what we have to do? First, we can see how many surfaces are there in the cube. Cube re roichi. This is the left surface, this is the right surface, this is the up, this is the down, and this is the front, and this is the back. छोटा surface रही से भितर x axis सहित जो माने normal ही कि अछंती माने left and right केवल left and right पई हमें पाइबा केवल left surface रो area होची area vector in this direction एपटे रहला right surface रो area vector ए direction ए दुटा पई हमें पाइबा. So flux linked with left and flux linked with the right surface, because आउ समस्ते कौन हेबे ना x axis सहित area vector normal रहिबो केवल left और right रो area vector रो direction. Area vector means normal to the area parallel रहिबे बा 0 बा 180 डिग्री करिवे. तेनु phi l left side रे हम पकेबा electric field केते alpha x to the power half. Alpha is 800. X means the distance of the surface from the origin. Distance kete a माने kete 0.1 रो power half. So eta hochi electric field along x axis I cap dot area vector. Area eta gote square हे जिवो cube रो गोटे surface होची square. So square means 0.1 square into it होची negative x axis सेति पई minus I cap. Surface रो area direction ला negative axis minus I cap. Right side रे सेमति केते पाइबा 800 into x. X means right side ta origin to kete distance rachi 2 into a. This is important. A is 0.1. 2 into a. Okay. To the power half. 2 into a. 2 will be inside the bracket. 2 into a 0.1. 2a to the power half into it is I cap dot area is again 0.1 square positive x-axis, and total flux how can find phi l plus phi r. After adding you will get the value phi l plus phi r will be equal to 1.05. Let us check it. Newton meter square per coulomb. So after getting phi you can get charge 1.05. So q will be 1.05 epsilon naught. एमिति ऑप्शन रे देथिबो in terms of epsilon naught. So these are some questions related to flux, and more questions I will provide in the group. So this is the end of the chapter electrostatics. So thank you. See you in the next chapter.